Why didn't we watch the episode?
What do you need help with 37, 38, and 39?
Me too.
We'll do it right after round one.
You bet I didn't.
Hey, just remember those, bring it up when we're done. All right.
Last Monday of September.
Okay. All right. Now, hey, here's the idea. Today, we're going to take a few notes. I got about 6 slides I want to go through today of vocab terms. I thought it was easier doing this than watching my terrible penmanship write all those definitions out. I'm going to post this online tonight. I don't think I posted yesterday's video. I'll post that online if you need to see it. I'll post it after school today. But today's video, I'll make sure I put the PowerPoint down there as well, in case you didn't get something you want to see another picture of it. Now, here's the idea. It's only 6 slides, and then we're done. After we're finished today with the PowerPoint, you can work on the 41 ask questions if you want to get it turned in. If you have any late work for me, get it turned in. All late work is due by next Friday. That's the midterm date. We have a 0 date coming up this Monday for, I think, page 18. So if you're missing a page 18 in the grade book, it's due by Monday because that's the 0 date for it. So keep that in mind. I'm going to hand back papers today once we're finished, really quick. And if you want to make fixes and turn them back in, they have to be turned back in by next Friday. Does that make sense? Yeah. Okay, you got a week or a little bit more to get all those corrections made. Okay, again, make corrections because I grade back up to 100% if you made all your correct fixes. Question, here, what do you got?
Are those things already indexed?
Everything's in. Your grades are 100% up to date as of this moment. The only thing I don't have entered is that page 41 you just put in my basket right now. Everything else is entered. Everything. So if you have an LI in the grade book, you didn't turn something in. So, or you still have. Okay, questions. Perfect. All right, here we go. We're jumping right in. Shh. Let's go through this quick so we can get done. Outline. Review. Here's the words that we need to discuss. It's not really a review. These are words that we've not used yet, but the concept is there. It's something that was actually on page 41. So the first word we're going to discuss today is adjacent angles. These will be bigger later. I'm just giving you the outline of what we're doing. So adjacent angles. The second word we're going to talk about is perpendicular. I believe we introduced the word perpendicular last Wednesday. When we did all the different classifications of angles. Angles were acute, right, obtuse, straight, and reflex. Perpendicular was one of the words we introduced in that slide, or in that lecture. The next word I want to talk about is the parts of an angle. Obviously, we've been discussing terminal and initial sides and the vertices, but how does that apply to these terms? That's what we need to look at today. Okay, do we understand the first basic 2 words here? We're going to get to these here in a minute. I'll give you the definitions. Those are my first 2 slides. Okay, the next few slides. The new words that I don't think we've ever introduced or ever discussed was linear pair. That's a word that we need to discuss today. The next word that we have is vertical angles. That's a new word that we have to talk about. And then complementary and supplementary. So there's 6 slides total. These 2 and these 4 down here. The 2 on the bottom are the words that on my next test we have. Our test in here is next Thursday, so keep that in mind. About a week from today, we have a test in here over this chapter. These 2 words from previous years were words that a lot of people miss because they sound too much alike, complementary and supplementary. They can't remember which one's which. I'm going to try to give you my shortcut today to help you remember it. It'll be stupid, but it'll help you remember which one's which. Okay. Questions that are outlined. Now, obviously, when we're finished today, we have homework, page 41's due. So if you have questions, that's the appropriate time to ask at the end. We should have plenty of time if we get through these slides. Questions so far? It's not. We can go quick. We should have about 20 minutes.
We're ready. No, we aren't.
Still right?
Okay, we're ready.
You ready? Yep. Anyone else need more time? Anyone else need to write those? Okay. We're good? All right, here we go. First word, adjacent angles. The definition, according to your textbook, the exact words the book uses, Two angles that lie on the same plane, same flat surface. They have a common vertex and a common side. So two angles, two separate angles that lie on the same flat surface, same plane, but they're sharing a common vertex and a common side. One of the rays is shared. So think about this. Think about two angles that are on the same surface. So if you're drawing them in your notebook, you have two angles. They're sharing the same vertex, and they're going to share a side. Think about what that would look like if you have that image in your head of two angles. They're on the same flat surface, they have the same vertex, and they share a side. Here's the image I have in my head. It's this. Two angles that are literally side by side. Because that's the English definition of adjacent. It literally means next to or side by side. So two angles, they share the same vertex. They share the same vertex, and then they share a wall down the middle. That's the idea. Okay, does that make sense? The idea of adjacent angles, side by side. Now, why I brought this up? It was something that was in your page 41 homework. If you have two angles that are side by side next to each other, that are adjacent to each other, you can add them together. You can make a bigger angle because they're side by side. So, you know, like in the homework, you might have a bunch of algebra here, where you had like 3x plus 1 and x plus 2. You could add them together, and maybe that makes a bigger angle. That's something you had to do for 9, 10, 37 through 39. But you had to label your pictures. I'll get to this idea of no interior points here in a minute. I'll explain that. That's one of the last things I'll explain. Just ignore that. That's why I put a star next to it. We're going to skip that right now. Okay, questions with adjacent. All right, now, adjacent can be any type of angle. So I showed a different picture here. These angles do not even have to be the same type. On this picture down here, angle 1 is obtuse. It's really big. Angle 2 is acute, but they're side by side still. They share the same vertex, and they share a wall between them, but they don't have to be the exact same angle. They are adjacent to each other. Now, here's the thing. I'm going to give you a picture on the board here. This picture, like you put in your notes, you're going to see one later I'll have on the slide. But this is something you just need to see so we can discuss it. All right. Let's call this 1, 2, 3, and 4. Those are my angles. I numbered them. All right. Now, on this random picture I've given you, can somebody just name one pair, just one pair, of angles that are adjacent to each other on this picture? Say it again? 3, 4. I agree with that. 3 and 4, these are adjacent to each other. They're literally side by side. They share the same vertex, the same wall. Somebody else now, what's another pair? 1 and 2. 1 and 2. 1 and 2 are adjacent to each other. They're sharing the same vertex in a wall. Okay, does that make sense? Now, here's my question. So think about this. Angles 2 and angle 3. Are they adjacent to each other? So look at the definition. And look at 2 and 3 up here. So yes or no? Raise your hand if you think yes, they're adjacent. Raise your hand if you think no, they're not adjacent. Good choice on the no. Here's why. They don't share the same vertex. If you can see this, because they have to be on the same flat surface. These angles are on the same surface, or on my marker board, right? They share a same wall. They share a common side. There is a wall between them. But the problem is, angle 2 and angle 3 literally have two different vertices. They have two different points where they're ending. So the idea is that they would not meet that definition. They are not adjacent because they're not physically side by side. They're pointing at each other. That doesn't count. Okay, does that make sense? They're not adjacent. Okay, now, the next picture I show you is about the same as this, and it's right there. So it's about the same looking picture. The book talks about this, and they put numbers everywhere, and they'll start talking about what's adjacent, what's not. It's the same picture you just saw here. Okay, now, the next picture I want you to look at is that one in the upper right corner. It's this one. I'm going to put it on the board so it's bigger. So, here it is. Alright, A, B, C, and D. Okay, so if you couldn't see that picture, here it is. Okay, here's the angles I want you to compare. I want you to compare angle number 3 and angle ABC. 3 and ABC.
Casey Brown to the office, please. Casey Brown.
Okay, so angle 3 and angle ABC. So 3 is this angle right here, it's kind of labeled. ABC is this large angle, this one. Are they adjacent to each other?
No. It says no interior points.
Okay, now you read through the bullet there, right? No interior points. You cannot have another angle inside another one. Angle 3 is literally inside angle ABC. You nailed it on the head. They can't share interior points. They can't be overlapping each other. They have to be side by side, no overlap. These, if I would have put angle 3 like down here, we would have been fine. Because it would have been angle ABC and then angle 3. They would have been side by side. You can't have overlap because of the interior points I did. Okay, questions with overlapping. That is not adjacent. Okay, I just thought it was something we'd better bring up. Okay, next slide. Let's jump right into it. Let's keep moving because I want to get through these pretty quick. Okay, next word, perpendicular. Think back to last Wednesday. Maybe you even have the notes in front of you. What type of angle is also known as perpendicular?
Straight.
Ooh, we got a couple of words.
Straight.
Right.
Straight, right? Which one?
Right.
Straight.
Right angles.
Oh.
Right angles. Perpendicular was one of the key words we talked about when we talked about rights, 90-degree angles. We had the word perpendicular, orthogonal, flush, and square. Those are the words we use for right angles. But why do they have all these fancy terms? Why don't they just call them right angles? Why do they have to have the stupid word perpendicular? It's the idea is that the word perpendicular is to describe the objects making the right angle. Right angles are 90s. But the actual physical objects that make the walls, they're said to be perpendicular to each other. So it's the actual lines, rays, or segments making the right angle. Those are perpendicular. So here's my picture. This is what most people have in their image of a right angle. They have like a T intersection, right? And they have that little box in the corner. That little box signifies that you have a right angle, 90 degrees perfectly. Well, the idea is that if you want to talk about the right angle, well, fine. You can talk about the 90-degree angle in there. But if you want to talk about the walls, AD and BC, the walls are perpendicular to each other. Now, we have a symbol for perpendicular. Now, the reason I bring this back up, this is a symbol that introduced this section, section 1.5, and they never tell you what it is. They just start using it and they never explain why. Here it is. Here's the weird symbol. It's an upside down T. That is not a misprint. It's an upside down T. Anytime you see this in the book from now on, that is a perpendicular symbol. That means how I literally read this out loud, this is how I read it. Line AD, that's that line, is perpendicular to line CB. They're perpendicular, they're literally making a 90-degree angle. The reason why they use an upside down T, T intersections are 90-degree intersections. That's why they use an upside down T. Does that make sense?
Yes.
Okay, they'll use the symbol a lot. Get used to it. Sorry, they don't really even tell you where it comes from. So there you go. All right, next term that we need to discuss. Got to talk about linear pair. I'm jumping a little bit out of order. Go with it. Okay, linear pair. Obviously, a pair means two. Linear means a line. So, it's two angles that are adjacent to each other that form a line, that form opposite rays. A line is also known as opposite rays. So, a pair of adjacent angles, angles side by side, that form a line, form opposite rays. Now, they use these fancy terms like non-common sides, blah, 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 whatever. They're side by side, they make a straight line when you look at it. In fact, we had to do this on your page 41 stuff. You had to notice that, you know, certain angles were adding up to make a straight line. You had to just see it. So I'm going to give you a picture here. This is the image that I always kind of have in my head. All right, two angles, they're literally side by side. They're next to each other, so they're adjacent, and they make a straight line. Does everyone see that that looks like it's straight?
Yeah.
So what you can do here, like this is what your homework was kind of looking like on 9, 10, 37 through 39. If they give you weird algebra, like 3x plus 2 and x plus 5, you can add these weird things together and set it equal to 180. Now, most people when they see that picture, they can go, okay, yeah, that looks like 180. It looks like a straight line. Let me give you another picture next to it. Does this second picture look like a straight line?
Absolutely.
Absolutely not. Because the human brain, the human eye, can pick out within 1 degree difference. Like this is a significant difference. Like if I were to make this straight, I'm off by almost 20 degrees here. But you can see that it's not a straight line, it's bent. Those are not linear pairs. They have to make 2 angles that make a straight line. Okay, questions with what a linear pair is? The last slide we do today, slide number 6, this is slide number 3. Slide number 6, that slide is going to talk about a different topic, but I want this word in your head. Keep linear pair right now. When I ask for it later, I want you to remember this word. Linear pair. They are 2 angles side by side that make a straight line. Got it in your head? I'm going to call for it later. All right, let's go to the next word. Vertical angles. This is slide number 4, I believe. Okay, vertical angles. They are angles formed by the intersection of straight lines. Angles formed by the intersection of 2 lines. So, without me even drawing this, here's what I like to do. In your notes, when you have this written down, because I know some of you are still scrambling, draw 2 lines crossing each other. 2 straight lines that cross. I don't care how you draw it right now. 2 lines crossing. Now, when you draw your 2 lines crossing each other, what does it look like to you?
Cross.
Cross and X. You have that image in your head, right? Like everyone kind of has the same looking drawing. When you draw straight lines that cross, this is kind of the image most people have. It's a cross, it's a X, it's a T. They just have that same drawing. This is what's forming vertical angles. The angles that are actually numbered, there are certain pairs that are vertical. The ones that are vertical, this is what they say. The vertical angles are the non-adjacent ones, the ones not next to each other. So can somebody pick a pair of numbers up here that the angles are not next to each other? 1 and 2, those are vertical to each other, or 3 and 4. Okay, so these are vertical. And then 3 and 4 would be vertical to each other. It's like a little funnel. What you need to know right now, vertical angles, they're equal. So somebody give me a number between 1 and 90.
87.
Okay, I heard 85. I'm going to go with that. I don't know if I mixed 2 together there. 85. That angle can go all the way to the other side, and this angle is also 85. They can just transfer straight across. That's what vertical does for you. It's like a funnel. Now, the image I always think of, other than the straight lines crossing, they have to be straight lines crossing. There's this toy I had when I was a kid. They still sell it in Hobby Lobby today. It's this little plastic cylinder piece. It's really small, it's about 1 inch tall. It's hollow, it's got threads on the inside, and you can literally like attach 2 pop bottles to it. Okay, you can like thread 2 pop bottles that are attached at the necks to each other. And if you put water in one of them, and then you turn it over so the water's on the top, and the water starts going towards the bottom, what will happen is if you spin it, it'll make this weird, crazy, like tornado vortex thing. And the idea is that what happens on the other water bottle that's empty, the tornado will come out the bottom and it'll be completely upside down like a perfect mirror image. Because what it's doing, and I had it when I was a kid, probably still have it, it's making a vertical angle. It's doing simple math. It's doing what you just saw there, where the angle going in the funnel and out of the funnel are the exact same number. So the image will be exactly the same. That's the idea. It looks really cool when you make one of these and you have water, but you also put oil in it, because the oil won't, it won't sink. So like the tornado will always go to the top, and it looks really cool. All right. Questions at all about vertical? Okay, now I'm going to show you a picture of a picture that is not vertical. Here's my image. These angles are not vertical. Now here's why. Do you agree those are not straight lines?
Yeah.
Like
Agreed.
this one might be straight AEC, that line A to C, but this line B to D is definitely not straight. It kind of had a weird flex in the road. It's off by about 10 to 15 degrees. Vertical doesn't apply. Like angles don't transfer on that one. They have to be perfectly straight for the angles to go across. All right, last 2 slides. Here we go. Complementary. Complementary angle. two angles that have a measure that's sum of 90 degrees. Two angles whose sum is 90 degrees. So think about this. What does the word sum mean?
Addition.
Addition. That's what you learned in algebra, right? They're adding. You have two angles that are adding to make 90. That's complementary. Two angles, the sum of 90. So here's the picture I always have, right? You'll probably do this a lot in this next homework we'll eventually get, either tomorrow or Monday. But you have two angles, they're side by side, and they're making this perfect 90. So if I did some weird algebra in here, like x plus 5 and 2x plus 10, I could add these together and equal to 90. They add to make 90. Those are complementary angles. Now, if you look at the definition, here. Did they say the word adjacent anywhere up here?
Yeah.
There's no the word adjacent. So here's the weird thing. They don't need to be side by side. They could literally be across the picture, like across the drawing of your book. As long as the two numbers add to make 90, they're still considered to be complementary. They could be across the picture. As long as the digits add to make 90, that's complementary. Now, to remember complementary versus supplementary, this is the part that most people have troubles with. Complementary, this is my easy way of remembering it. My way of explaining it to you so you don't forget. The first two letters in complementary are C and O. That spells the word corner. And corner and complementary have the same first two letters. Complementary corners. Corners are 90 degrees. That's what you hope to have in your room. 90 degree corners. Does that make sense? I know it's stupid. That's the image I had, so I remember complementary. Okay, we good so far? Okay, last slide. Here it is. Slide number 6. Okay, slide number 6, supplementary. Supplementary, two angles whose measure sum to be 180. Two angles whose sum makes 180. Now think about this. What was the word I wanted you to remember a long time ago? The word I said I don't get. Linear pair. A linear pair are supplementary to each other. Because the two angles, they're literally side by side. That's a linear pair. They're side by side. They make a straight line. Straight lines are 180. In fact, that's how I remember the word supplementary. The beginning letter of supplementary is an S for straight. This spells the word straight for a straight angle. So complementary is a corner. Supplementary is a straight angle. Now, did they say the word adjacent up here anywhere?
Nope.
So they don't have to be a linear pair. A linear pair is when they're side by side. They make a straight line. If they're not side by side, they're not a linear pair, they could still be supplementary. I could still have 120 and a 60. These still add up to be 180, even though they're not a linear pair. They're not side by side. Linear pair are adjacent. Supplementary doesn't have to be adjacent. Okay, questions at all about the terminology we've used today? Okay, we're done for the day. Page 41, if you have questions, I'll answer that here in a minute. I'm going to hand back papers first. It'll take me 2 minutes to do it. You can make fixes. All those papers I hand back to you have to be back by next Friday. That's the end of midterm. This Monday is, I believe, the 0 date for the page 18 if you don't get that one back. Now, if you have not turned in 41, that is due today, so make sure you get that turned in. I got a lot of people turning in, which is a good thing. Sure good name. Is this your paper?
I right there. Look at Emma, and then I put goal under it. So that was wrong. Get it done. What?
Yes, leave 5 minutes early over there.
I fixed this. What,
AE or
Thank you.
What am I not fixed?
What I missed, Al.
Bills.
You still missed that?
I'm
Take a survey and it says,
I didn't call it.
Wait, we changed it, we still got her on.
Smith. Sarah.
I got one.
Okay, the papers will hand back. If you make fixes, turn them back in, all that good stuff. You guys know the drill. Everything's in the grade book 100%. Yeah, if you don't want to make any fixes, you can recycle them.
Hey, Brady, can you put us in the recycler?
What's that? Wine.
Yes. Mine's hard, and I might not even have it because the girl might tell me.
No, I think it's fine. They push out around here and you don't see more. You come all the way down. The elevator. And you know how there's that little hill? Like turning out the lines. Like it just bites out like
You can get that.
I know. I was spinning because it's raining. I was spinning.
Julian.
What?
So bad.
I don't have to. I learned. I have to clutch. I learned to clutch. I go, what?
Yeah, you know. Yeah, on the survey it says, what do you call it? Apparently, some actually say that.
Brown.
They only been sitting in my locker.
Wait, I'm not.
We throw these away.
You can't get recycle if you don't make any fixes.
Wait, that's good.
How long does it take you to wash your wash?
Sarah?
Hold up, what is it out of?
I don't even remember that.
I'll wash them right
You stay at home.
All my names are
National Cup 2 to make sure I got put
every single off at 5
Great move.
Cash. Is this yours?
Yes!
Your name on it? Turn it.
What?
Heckman.
Can we throw these away?
Ganger.
Yeah, you can recycle.
Yes.
What'd you put?
If you have 8%, that instantly boosts up like way. Having 0 is like a even any percent bigger than 0 is always way better. Yeah, I think I'm turn it.
Everything. Do you look at that? Is it on still?
Yeah, I just kind of glance through. If there's any knucklehead action in there, I just kind of. If there's more than one that I have to like edit out, then usually I can edit it. Usually it comes down to how long did it take me to edit, and that's how much detention you get.
I'm definitely in that video of dropping my cough drop. What? I got my cough drop and I never put it before. It's in the video. I'm in the video.
Like me, white trash.
Yes. Weird.
Bigger.
Yeah, I got 27.
He's on a few minutes.
Dude, if he wouldn't listen to us.
Oh, this is the wait, was that out of 40?
I need help with myself.
Oh,
I got I missed the
Alright, Dietrich, fire away. What's your question?
Hey, we have
No holds barred. Fire away.
37, 38,
Yeah, 37.
we don't have the video.
You do.
It's that.
I got it. If F, whatever that little line thing is, and that angle thingy,
That
I was using F, was 4N minus 13.
Maybe, okay. So, if you notice in the book, if you saw the pictures, did you notice they have this little red marker here? What does that red marker mean? Centimeter. Centimeter sulfur.
Oh my.
Now, once you're done, then plug it back into something that will aid you. So let's say your N happened to be let's say it was 10.
Maybe I
Plug your 10 back in and solve it. Make sense? Okay, now some of them you might have to just like put in there, and then maybe have to add all the way up to make 180 or something. So just pay attention to like what they do. I always draw it like.
Yeah, I was thinking about that. I was like, good luck. I want to I don't get what I do. You know, mom's strong.
Yeah, junior year of high
Three boys and then because when you yeah, but if you're not negative, it should be a positive. It should do a positive. Just switch them to the opposite side.
Two is wrong.
I'd be 105.
What'd you do? I was going back up because I sit right next to it.
No, he switched it up. So I got to take out of the
Hey, sure, if you got another
and then you
question,
have
fire
to
away,
put it
whatever you got.
Where the says number fan letters or letters? Is it just over the alphabet or is it over?
Some of them are insane.
For page 18, would you get rid of the D?
Yeah.
Is our test the numbers?
How do you draw?
Why do we have the whole thing?
I think I have to plug it back in.
That's the what?